Have you ever looked at an AI-generated face and wondered, how did the computer dream this up? It's not copying a photo, it's creating something brand new. Today, we are decoding one of the most fundamental tools in generative AI, the Variational Autoencoder, or VAE. If you want to understand how AI imagines new data, you need to understand this. First, let's verify where we stand. Traditional AI is like a critic. It looks at a picture and says, that is a cat. A VAE is different. It is a generative model. It's like an artist. It learns the rules of what a cat looks like so it can draw a completely new one. VAE stands for Variational Autoencoder. It's a type of neural network that learns to compress data and then reconstruct it, but with a special twist that creates creativity. Think of a VAE like a sandwich with 3 layers. Layer 1 is the encoder. Layer 2 is the latent space. Layer 3 is the decoder. The encoder takes your input, say, a photo of a dog, and compresses it. But here is the magic. Unlike a standard autoencoder, it doesn't compress it into a single fixed code. It compresses it into a probability distribution. This means it doesn't tell the computer, this dog is exactly at point X. It says, this dog is somewhere in this general area of fluffy, brown things. This area is called the latent space. Then, the decoder takes a random sample from that area and tries to rebuild the original image. Because there is a little bit of randomness, the decoder learns to understand the structure of the data, not just memorize pixels. Why do we need the variational part? If you use a standard autoencoder, the latent space has gaps. If you ask the AI to generate something halfway between a 1 and a 2, it creates garbage. But a VAE creates a continuous, smooth map. If you slide between a 1 and a 2, the VAE will actually generate a new number that looks like a mix of both. This smoothness allows us to edit features, like making a generated person smile or adding glasses, just by doing math in the latent space. So, what is this used for in the real world? Anomaly detection. Factories use VAEs to spot defects. The VAE learns what a perfect product looks like. If a broken part comes along, the VAE fails to reconstruct it properly, triggering an alarm. Drug discovery. Scientists use VAEs to generate new molecular structures that could become future medicines. To summarize, a variational autoencoder compresses data into a probability cloud, allowing it to learn the essence of the data and generate new, similar variations. It is the bridge between simply storing data and understanding it. If you found this helpful, hit that like button and subscribe. Let me know in the comments. Do you want me to explain GNs next? See you in the next video.